Hi, welcome to this ZP FoodSense webinar. So we like to do this webinar once a week, and it's just answering technical questions that have come in during the week. I will be doing a demonstration shortly because it's easier to answer these questions that have come in this week whilst demonstrating. And when I say demonstrating, I will be using the FoodSense Generation 4. I'm also going to do a test on blood glucose as well today as well. Sounds a bit strange, but one of the questions, I find it easier to actually answer it by doing a blood glucose test as well. So we will be testing chili, a chili product on the FoodSense Generation 4, using that to answer questions, and then also I'll be drawing some blood and testing my blood glucose. So you'll see why I'm going to do that shortly. But it's worth saying that for FoodSense Generation 4, we provide personal online training. So please, if you're a reseller, distributor, or you've a customer, whatever ways you came to the FoodSense Generation 4, please make sure you get your personal online training. Please know that we do weekly webinars. So this week I've got 3 quite simple questions. One of them is about temperature, one of them is about calibration, and one of them is about how do we kind of know that the instrument's not drifting. So I will answer those 3 questions. We do monthly webinars. Also, one of the questions I realized was actually about how long to leave the sample on the sensor before actually making a reading. Anyway, that said, there are 3 simple questions. I can quickly answer them. I will do a demonstration when I'm answering it. If you want a deeper dive into FoodSense Generation 4, there's actually a webinar next week. Don't worry if you're watching this video post 29th of August 2024. The link that I'll put underneath the video will always take you to the it'll take you to the webinar that's coming next in the series, so don't worry about that. We always do 2 on the day, 1 in the morning, 1 in the afternoon. The 1 in the morning works well for Malaysia, Singapore, India, Australia, New Zealand, China. The 1 in the afternoon works well for back end of Europe, and also works well for the Americas as well. Questions number 1. Will the temperature of the sample be... Now, this is an important question. Will the temperature of the sample affect the measurement accuracy? So, a few things on temperature. So, first of all, I'll just change my screen real quickly. The instrument itself, and... the instrument itself works well in the range 20 to 28 degrees C. This manual is actually really good. It's very comprehensive. It's also quite thin, but the thinness is actually because of the simplicity of the instrument. And you're going to see the simplicity of the instrument at the moment. So the instrument itself should be at a temperature of 20 to 28 degrees Celsius. Now, I appreciate that this instrument is actually being used a lot in India, and then to lesser degrees in Malaysia, Singapore, Indonesia. But I do appreciate these places are at temperature, can have quite high temperatures and humidities. But that said, this, even though it's a very elegant, easy to use instrument, in the end, this is a scientific instrument, and it does want to be used in the temperature range 20 to 28 degrees Celsius. Now, the question is slightly different. The question is, what if the sample is hot? So let me just do essentially a quick demonstration to illustrate that. Well, yeah. What I'm going to do is I'll take this sample. So I'll take a chili sample here. And I'm going to take this pipette. Now this pipette, I'm actually going to take 50 microliters of solution. So here's my finger here. The reason I say this is really important, because even if something is hot, if you take 50 microliters of something, 50 microliters is a tiny amount of liquid. So by the time I've taken this sample, by the time I've moved this sample over to here, by the time I've put it on there, that's a tiny volume. That volume is not going to hold on to temperature. So if it's coming out at sort of 70 degrees C or 50 degrees C, it's going to cool very quickly. So the quick answer to your question is the sample should really be at 20 to 28 degrees Celsius. A sample that size in an environment that's, say, 25 degrees C, it's very quickly going to get to 25 degrees Celsius. So I can understand. So maybe, when somebody's trying to test something hot, if you put it in a little vial like this and just leave it a minute or so, it will soon be at room temperature. So liquids, especially 50 microliters, will not hold on to their temperature that much. They're a very small, essentially, object with quite a large surface area, so they'll actually lose their heat quite quickly. But the quick answer to your question is, in accordance with the manual is very thin, very comprehensive. It does say the system should be at 20 to 28 degrees Celsius. I'm sorry, it's a bit bright there. The sample should really be in that temperature range as well. But honestly, you should find that a 50 microliter sample is a very small drop. It will very quickly lose its heat. I'm actually, but I'm not going to run this now actually, and I'll tell you why as I go through the questions now. Second question is right. We don't need any standards to test the FoodSense Generation 4. And people find that unusual. And then I'm not sharing the screen, so I'll share the screen with me. I'll share the screen, sorry. Why don't we need any standards? So for example, if you're measuring pH, people will have calibration solutions next to the pH meter. The nice thing about the question is that Zimmer and Peacock, you may know us through these videos for FoodSense Generation 4. We're really possibly one of the leading technologists in the world on electrochemical sensing. So in fact, we really do understand pH, by the way. It's a potentiometric methodology, and it requires a lot of calibration. I'm going to answer the question in a slightly unusual way. Right. So in 2000, I started my career making these. Not these particular ones, but I worked in what's called making glucose strips for diabetics. So let me take this glucose strip. Let me put this glucose strip in that instrument. Let me take this thing for pricking my finger. Let me get some blood out. I didn't push very hard because I was feeling a bit squeamish. There we are, I got some blood out now. And I'm going to put that now on the device. And that's running. It's really important to understand that whenever I use this machine, so my blood glucose here is actually quite low. Actually, I'm quite surprised. It's 89 milligrams per DL. The ideal blood glucose is actually 90 mg per DL. So it's only 1 mg per DL off. Now, the reason I do that is I did no calibration. I never test this instrument. Understand that FoodSense Generation 4 has been designed to be much more close to a glucose strip. You can even see it in our technology. See this? That's very much equivalent, or a similar technology to a glucose strip. We're actually using the same kind of science. So when we designed FoodSense Generation 4, we wanted it to be calibration free. And so you use the analogy of the pH sensor, and I said, yes, I understand pH sensing. It's a potentiometric, or they measure voltage, and that voltage is indicative of the hydroxonium ions in the solution. So I do understand that. But that's a technique where actually you need to quite regularly calibrate it. Can I ask you about another electrochemical sensing technology, a glucose strip? Glucose strips are used, there's millions of glucose tests done per day by diabetics. There's no calibration involved. So when we designed this, FoodSense Generation 4, we were actually designing it to be much more like a glucose strip than we were designing it to be like a pH meter. And so we designed it to be calibration free built into this. Now you asked the question here, what about drift? So in fact, let me answer that question now. I'm not going to run this sensor because in fact I put the sample on there and I didn't run it, and that'll be your question number 3. But let me just get to I'll just do a quick run now. So forgive me while I just do this real quick. FoodSense Generation 4 quick demonstration. I'm just going to, what I want to do is question number 3, you're actually asking about timing. So I'm going to come to question number 3 in a minute. But in preparation for that, I'm actually going to do something. I don't really emphasize this so much sometimes when I'm actually doing demonstrations. But what I want to do is I'm going to do a test. But in fact, something we don't emphasize probably enough is I'm going to get that sample, I'm going to put it on the sensor, I'm going to start the test immediately. Because actually, capsaicin is an organic molecule. The longer I leave the sample on there, the drop will start to evaporate. As the drop evaporates, the capsaicin will enrich. And so the sample becomes more concentrated. So in fact, I want to take that drop, I want to put it on that sensor, and I want to run it immediately. So there's evaporation. Could be, if you leave it standing too long, evaporation could be a problem. There's also that capsaicin is an organic molecule, and it will start to stick to the sensor and enrich upon the surface. So question number 3, you're actually asking about, the timing of doing this. I've got the sample, I've put it on there. I'm not rushing, but I didn't leave it super long. So if I just check, I'm just going to check this. Just going to change screens for a second. It's just running and doing its thing at the moment. Let me just check screens. Yes, how many seconds? You do ask in this one. How quickly should you do it? Well, the quick answer is I took the sample, I put it on there, I let it running. Now I'll just go to here. It's just coming to the end of its run at the moment, and it's come to the end, and I've got a result. Your question number 2 is you're a bit concerned and I'll go in question number 2. You're kind of saying, well, I don't need to calibrate it. How do I know this machine is not drifting? And it's actually a good question. How do I know this machine's not drifting? So what I'm going to do is I'm going to share my screen with you. If I just hold this up for a second, I've got the result, and it also says upload complete. This is an amazing piece of technology, because actually what it's done is it's given you a nice, clean, easy answer. What I mean by that is it says the Scoville heat units are, I'm just going to have a quick look, 3,120 Scoville heat units. Nice and clean, okay? Now what it's done as well is I'm just going to share my screen with you. And it's sent the data straight to the cloud. So in that cloud, I can see the data. And in fact, that 3,020, on the app, it rounds it up nicely. But in fact, what it did is it rounded up from 3,118. Do you understand that a difference of 2 on a scale of 3,000 is absolutely the same number? It just rounds it up to make it nice and clean looking on the app. But in reality, it's actually on the cloud system. It's not 3,120, it's 3,118.963. But we round up to the significant figures. Now, the reason I'm bringing this up is because on question number 2, you were a bit concerned about calibration, and you were a bit concerned about drifting. This is the amazing thing. See, this machine, you can come in here, we can see the raw signal. And, this is very distinctive. I know that you've watched our webinars before and you've attended our webinars. We call that peak 1, we call that peak 2, we call that peak 3. Do you understand that actually these peaks, we can almost see their heights, we can see their positions. If this machine was, let's say, messing around or breaking, I'll have a quick look here now. This is not, this is data where I put no sample onto it. But the raw signal is almost like a health indicator of actually that this machine is still operating well. So you can always check yourself for your client, or you can actually share the data with ZP as well, and ZP can check it. So the answer to your question is this is not operating the same way as a pH sensor. A pH sensor is using a method called potentiometry. This is actually using a patented technique called cyclic voltammetry. The next part of the answer is we don't calibrate regularly, because actually I started my career making glucose strips, and we were very keen to give that very good user experience when in fact you manufacture sensors, you put the sensors in the meter, you put the sample on there, you get the result. You never ask a diabetic to calibrate with these kind of machines, and we've actually built the system to be the same way. Does the machine drift, or rather, can you check for it? Actually, because you get the raw signal, we can always see if there's a problem. There's I might have one here. In fact, if there is a problem, and you've got something like that, you would just see it straight away. You're not obliged to look at the cloud, but the cloud actually does give you indications of when things go wrong. Whenever I'm showing you stuff go wrong here, by the way, it's because I've deliberately done it. It's not like this machine's going wrong all the time. What I'm going to now do is I'm just going to slightly change back to your questions. And then question number 3 here, you said, after we drip the sample on the sensor, do we need to wait? No. What you should really do is actually have it ready to go on the app so that you can just hit go to assay and start almost immediately. Because I know you can imagine this, but you know, the drop that we put on these sensors is really quite small. It's a very small drop. So you could appreciate that actually if you left it sitting there, it could evaporate with time, and that would definitely enrich the sample. But also capsaicin is an organic molecule. It loves to stick to surfaces. And so it could actually effectively enrich on the surface and give you an artificially high result. So sample on, don't need to rush it, but you know, a few seconds later you should be starting the assay. And I think with that, I want to say thank you. I appreciate the questions this week. They're very practical. Just remember that this unit would like to operate in the temperature range of 20 to 28 degrees Celsius. I appreciate that in some parts of the world, that's, you know, places are warmer than that. And I understand that. But this in the end is science. And, you know, we do have to control the variables to some degree, and we can't be operating at, you know, I mean, sometimes things can get up to 40 degrees. I appreciate that, but it's not what this instrument is designed to do. If you have any questions, please don't hesitate to reach out to us. And as you can see, we're quite happy to answer questions. We'll even bleed for our webinars as well, if that helps in the explanations. Okay, take care. Thanks very much.